Hello, in this video we are going to learn about angles, the introduction to trigonometry, which is almost purely based on angles for the entire year. So we're going to start with these angles that are in standard position. So in trigonometry, almost exclusively with a few exceptions when we're talking about bearing, which are a different place, we will be measuring angles that start at 0 on the x-axis, and then they go counterclockwise, and they go around. So when we measure these, this will be 0 degrees, this will be 90. We have 180 degrees as we go around, that's 270 degrees, and then we get all the way back here, which is 360 degrees. So when you measure an angle, this is your starting point here, and then your ending point is wherever it is that you end. Let me straighten this out so it actually looks like a 90-degree angle. And then your angle ends somewhere else. Let's just say that it's here. And so this is the measure of the angle. It starts at 0. This is the starting point at the bottom. And then this is how far it moves. And so this would be, I'm just going to put an amount there that, say that that's 120 degrees here. Okay, and then that would be that angle. Now, you can also measure angles in the negative direction. And so the ending side is called the terminal side. So you can see over here, that's the terminal side, initial side. Initial means start, terminal means end. Okay, so start for the initial side, terminal side. If you go in this direction, it's positive. Okay, counterclockwise, it's positive. If you go actually clockwise, that's a negative angle. So in this picture that's here, you should be able to figure out how big that angle is on this side. Okay, so some of you probably already have the answer. The angle that is in this direction that goes clockwise, because the one going counterclockwise, the positive angle, this one right here is 120 degrees. Then the one going in the opposite direction is negative 240 degrees, because the entire circle is 360 degrees. We also have 4 quadrants here. So as you go up in this direction, we start counting. So this is quadrant 1, then quadrant 2, quadrant 3, and quadrant 4. They use Roman numerals. I will go ahead and write these in here in this manner. So that's quadrant 1. This is quadrant 2, quadrant 3, and quadrant 4. All right. So when you're drawing these, I would like you to have 3 arrows when you're drawing these. Okay, 3 arrows total. So the first arrow will always go on the x-axis, and that goes for all of these. Please attach the arrow. Some of you like to, the arrow's not touching. It makes it a little bit harder to read when they're separate from each other. Some people draw it like this. I don't want you to do that. All right, so 240 degrees. So the second arrow will be this circle that you go around. So that's 90, that's 180, and then you have to go 60 degrees more. So again, 90, 180, and then 60 more degrees. And it's trying to think, it thinks I want to draw a circle. So let me do that again, not hold down too much. I would like there to be an arrow there as well to show what direction you're going in. Because if this arrow is not there in the middle, if that arrow's not there and you just have this picture, then it's not understood if you went this direction or if you went this direction. And so you need to make it clear that you went in this direction. counterclockwise, so that's positive. And you can write the 240 here. What happens is that sometimes the angles will go around more than once, and then you can't really write the angle on the inside. And so I'm going to go ahead and have you write that out here. That's 240 degrees. For negative 50, and then try to draw it to scale, please. So negative 50 is almost in the middle. Okay, so I'm just going to draw the other end of it. 45 would be exactly in the middle. This is a little bit bigger than that. So that's negative 50 degrees. Or you can write it here. For 150, 150 is, this is 180 here. So it's 30 degrees from that. So this part right here is your other arrow. So that's 150 degrees. Or 150 degrees, make sure you use a degree sign. For negative 300 degrees, so in this case, you're going in this direction, okay, until you get to negative 300. So you have to figure out where that is. So this is 90, 180, 270. Right here is 270. So we have to go 30 degrees more. So your angle is going to be right there. Okay, so 30 degrees past the 270. And this arrow, that's terrible. And this arrow will go in this direction, and that's negative 300 degrees. Okay. All right, so again, those are those angles. If they're less than 360, these angles, you can shade them in if you want. But if they're more than 360, obviously you can't not do that. Because then it would be, you would basically shading in everything. Okay. All right, for the next part, this is just a little description. We don't really use these very often or very much throughout the year. I'll kind of point out things that are a little bit more important. We will cover this in this chapter. So acute angles are angles whose measure is between 0 and 90 degrees. The reason I don't say from 0 to 90 is because you cannot have a 0-degree angle and you can't have a 90-degree angle and call it acute. So it's between 0 and 90, so it does not include. If you want to write that out mathematically, it would look like this. The angle would be between 0 and 90 degrees. And you would not use an equal sign down here because you can't have it be equal to 0 or 90. Okay, so for a right angle, it's exactly 90 degrees. For an obtuse angle, it's, and hopefully maybe you can remember some of these, between 90 and 180 degrees. Let me draw a picture of what they kind of look like. So an acute angle is small. A 90-degree angle is exactly 90. An obtuse angle. And then we have a straight angle. So I know for a straight angle and a straight line, people think they're the same thing. The line is just the line. The angle is the 180 degrees from here to here. Okay, so that's 180 degrees, so that's a straight angle. When you draw a straight angle, it does form a line. For complementary angles, again, if you can remember what these are two angles whose sum is 90 degrees. Now, please don't say two angles that are 90 because they are not each 90. Two angles that add up to 90 degrees or whose sum is 90 degrees. And they could either be next to each other. such as this picture here. So if I said angle 1 and angle 2 are complementary, or they can not be. So if that's 40 degrees, and let's say that this angle is 50 degrees, and that's angle A and angle B, then angle A and angle B are also complementary angles. Supplementary angles are two angles whose sum is 180. So again, they could be adjacent to each other. Adjacent means next to. So these two angles, let's say that, I don't know, it looks like 40 and then 140 degrees. Those two angles are complementary, or excuse me, supplementary. Or they can be non-adjacent angles. So I can say that that's 120 and this angle is 60 and they add up to 180. Okay, if you have a hard time remember which one's which, supplementary sounds super big, so super supper, and supplementary would be 180. Next one, it says finding complements and supplements of an angle. Again, try these ahead of time. You should be able to do them with before I show you what those answers are. So there's an angle that's 40 degrees. The complement of that angle would be 50 degrees because it adds up to 90. And the supplement of that angle would be 140 degrees because it adds up to 180. It's actually just like that. The difference between the complement and supplement will always also be 90 if you want to kind of check that. For the next one, this angle is 55, so the complement is 90 minus 55, which is 35 degrees. And the supplement will be 180 minus 55, which is 125 degrees. For example 2, they just want you to find the measure of each angle in the given, says given figures. So you need to solve for x first and show how you do that, and then you need to solve for each of the angles. So all of the angles here that look like right angles they don't have a box, but they are right angles, and all the straight angles are straight angles. So in order to do this, to solve for x first, you would make an equation, 6x plus 3x equals 90. So 9x equals 90, so x is equal to 10. If you plug that 10 into these two, then this angle is 30 degrees and this angle is 60 degrees. And some of you may have figured that out before you actually solve for x. I do want you to solve for x, however. For the second one, these two angles, 4x and 6x, are supplementary, so they add up to 180 degrees. So 10x is equal to 180, so x is equal to 18. So if you do 4 times 18, this angle will be 72 degrees. And that means that this one is 108 degrees because they have to add up to 180. If you wanted to do 6 times the 18 to make sure, then you could. If you plug in 18 to the 4x and the 6x, and the two angles that you get don't add up to 180, then your x is wrong. That's how you would know. For number 3, and hopefully you did all of these now at this point before watching the rest of this, 2x plus 3x is equal to 90 degrees because this is 90. So 5x equals 90. X is equal to 18 again. So 2 times 18 is 36. And 3 times 18 is 54 degrees. And number 4, 7x plus 2x is equal to 180 this time because that's 180 degrees. 9x is equal to 180, so x is equal to 20. So this is 40 degrees, and this is 140 degrees when you plug x back in for x. For the next part, there's a few little things here when the measure of an angle. You can write it as a measure of angle A. We're not going to be really doing that much in here, to be honest, but it's worth mentioning. And then we're going to talk about in degrees, if you want to cut that down into smaller pieces in 1 degree, then they cut that. Let me just pretend that this is 1 degree, because obviously if I drew it 1 degree, it would be too hard. So that's 0 degrees, that's 1 degree. And normally 1 degree is obviously tiny, right? Since there's 360 all the way around. But if you wanted to cut that down into smaller portions than 1 degree, then they cut that down in something called minutes. So they cut this, and from here to here, there are 60 minutes between 0 and 1 degree. And then if you could take each one of those minutes, so we're going to pretend that this is a minute, and they cut that down into 60 seconds. So obviously that's not visually, like we can't see that visually, but again, if you take 1 degree, it gets cut down into 60 minutes, and that each minute gets cut down into 60 seconds. So the easiest way for our brain to think about it, I believe, is to think of this as hours, minutes, and seconds, because that's something that we're familiar with, okay? So really we have degrees, minutes, and seconds, which are written like this, okay? Degrees, minutes, and seconds. For the degrees, if you could just think of those as hours, then it'll be easier to kind of put this together in your head, okay, as you're doing this. So we have, for the first problem, 51:29, and we have 32:46. And again, this is degrees and minutes, but if you think of this as hours and minutes, it'll be easier. So when I add the minutes together, I'm going to get 75 minutes, and then I'm going to have 83 hours. But you can't have 75 minutes. Okay, and again, this is degrees. But if you have 75 minutes, that's really 1 hour and 15 minutes. So, or let me write it this way. It might be easier for you to see. This 75 minutes is 60 plus 15 minutes. Okay, these little dashes stand for minutes, and this is 1 hour, which is the same thing as 1 degree. So we're going to add 1 here. So we're going to have 84, and we're going to have 15. So 84 degrees and 15 minutes. Okay. For the next one, we have 90 minus 73:12. So instead of 90 degrees, we're going to call that 89 and 60. So again, think of this as 89 hours and 60 minutes, which is the same thing as 90 hours. And hours are the same thing as degrees. So 90 degrees is the same thing as 80 hours, 60 minutes. So we're borrowing an hour, or borrowing a degree. So when we subtract, 60 minus 12 is 48 minutes, and 89 minus 73 is 16 degrees, or 16 hours, if you want to think of it that way. Okay, so go ahead and try the next two and see how you do. All right, after you've paused that, let's go ahead and do this. So 28:35, and you don't need to put the units down while, you just need to make sure that the ones that are alike line up. Like there could be seconds over here too. They don't give us that in this case, but it's possible to have degrees, minutes, and seconds. So if I add these together, I'll get 91 here and 87 here. 87 is the same thing as 60 plus 27, so that's 1 hour. So I'm going to add that 1 hour here. So we have 92:27, and that's degrees and minutes. The next one, we have 180 minus 117.29. So I'm going to borrow from the 180 and make that 179 and borrow that 1 hour, which is 60 minutes. And so when I subtract that, I will get 62 degrees and 31 minutes. All right, so now we're going to convert back and forth from the degrees, minutes, and seconds. So this, you'll see this on your calculator. Some of these are easy to use and some of them are not so easy to use. You can check your calculator to see how well you can do on that. I generally don't use the one on the calculator I have. It's not very intuitive and I just rather do the math for it. And then, so we will be able to change from a decimal to minutes and seconds, okay? So here we go. So in order to do the first kind, if you're going to convert this 74 degrees, 8 minutes, and 14 seconds, then I know it's going to be 74 point something degrees. Well, 8 out of 60 isn't very much, so it's not going to be a very big decimal. So what you'll do in order to change this is you leave the 74 alone, and then you will do 8 over 60, so that's 60 minutes, so you're 8 out of 60 minutes, plus 14 out of, and so instead of 60, you have to do 60 and another 60 because you're taking the 60 minutes and then the 60 seconds, so you have to make that into seconds. So it's 60 times 60, so this will be 3,600. You'll do this all at once in your calculator, and that will give you 137. And that's the decimal point of it. So you just run 8 divided by 60 plus 14 divided by 3,600 all at once in your calculator. To convert back, you're going, instead of divide, you're going to multiply. So I already know it's going to be 34 degrees. And I just need to figure out the minutes and the seconds. So you take the decimal portion of this, okay, so decimal portion only, and we'll multiply that 0.817 times 60, and that's going to give me 49.02. And don't round anything here, and these are minutes. Now, even if you could round, I don't want you to round at this step. These are the minutes, the whole minutes. So that will go here. And now I need to take the 0.2 or 0.02 and I need to multiply that by 60. I don't need to multiply by 3,600 because it's already been multiplied by 60 once in the first step. And so you're going to be multiplying by 60 again in the second step, and that will make it into seconds. So that will give me, in the second part, will give me 1.2, and in this case is a seconds. And you do want to round here if you could, and if that was like 1.8, you would round that to 2, but in this case, we're just going to put 1. Okay, and that's seconds. So that's your final answer there. Please try 1 and 2 and see how you do on this one. So the answer to this one is 105 points, and then you're going to have 20 over 60, which I already know that that's 1/3 or 0.3. So I'm almost positive that will be a 0.3 right here. And then you have plus 32 over 3,600, so that is 0.3, but it's 0.342. If this wasn't here, this would just be 0.333 because 20 out of 60 minutes is 1/3. And that's degrees, so I do need to put a degree sign on that. We're just changing that into degrees. So, and then for the next one, we have 85 degrees. And it wouldn't matter if the 85 was negative, you would just put a negative. It wouldn't change how you do this problem at all, just for your information. So we're going to take the end of this part, this 0.263, and we'll multiply it by 60. And that gives me, excuse me, that's going to give me 15.78. So we use the 15, that goes here. This is minutes, and then we take the 0.78 and we also multiply that by 60. That will give me 46.8, and this is seconds. So we will take all of this and round it and write down 47. So you do not round in the first one because we have the 7/8 to still use, the 0.78, but you do round in the seconds because we don't have anything smaller than seconds, so we will round that part. Okay, so we have quadrantal angles here. Quadrantal angles are ones that aren't in any quadrant. They actually lie on the x or the y axis. So angles such as 0, 90, 180, 270, 360. Basically, any multiple of 90 is a quadrantal angle. And that's all really there is to know about that. Coterminal angles are angles that start in the same place and end in the same place, but take a different route to get there. So this angle and this angle are coterminal. Also, if I went all the way around and came back and landed there, then this angle and the same angle. So let me show you an animation of that so you can kind of have a better idea of what that is. So right here, this angle A, or not A, but CBA, let me put it at 40 degrees. The other angle, if I go around, you can see that the angle is at 400 degrees. Okay, so those are quadrantal. Also, if I went in the negative direction, excuse me here, let me try to give some more room. So if I went in the negative direction, then the 320 degree angle and the 40 degree angle are also coterminal because they start and end in the same place. Okay, so they get there differently. So 580, negative 580 and 140. Negative 220 and 140. So what you should notice about coterminal angles, if they start and end in the same place, is that they're separated by 360 degrees, okay? So, coterminal angles are basically 300, and their measures differ by multiples of 360. So, they want an angle of least positive, so the smallest positive. That's it. So smallest positive, they want one answer. So basically you will subtract 360 from this, and you're going to get 548. But then you can subtract 360 again, and that will give you 188. If I subtracted 360 again, I would be negative, and they want us to be positive. So 188 is coterminal with 908, and actually so is all three of these are, but 188 is the smallest positive one. And what that means is if you drew all three of them, they would end in the same exact place. So 188 is just past 180. So we're talking about this angle. And 548 would be the angle that goes all the way around again. And then 908 would be around one more time. Okay. So for the next one, we don't want to subtract 360. We want to add 360. That will give me 285 degrees. And that's the smallest positive. For the next problem, you'll add 360 twice. And actually, you're going to have to add 360 one more time. I'm not going to show all the work for that, but you end up getting 280 degrees. If you know that you're going to have to add 360 more than once, hopefully you know that you can add like 720, which is twice 360. That will give you negative 80 degrees, and then you would have to add 360 again. You can do all this on your calculator. For the next one, you would get 26 degrees. I'm just going to give answers for these. This one, 210 degrees, and for this one, 117 degrees. For the last two problems, these are word problems. They're fairly easy to do. You just have to kind of follow a pattern here, okay? So the first thing I want you to know is that a revolution is equal to 360 degrees. It means one time around something, okay? Same thing with one orbit. So one revolution, an orbit, is 360 degrees. I'm trying to think of what other words they use. A one rotation is equal to 360 degrees. So they'll be using the words like this throughout the entire year to mean 360 degrees or to equal 360 degrees. So it says CD players, back when we had those, always spin at the same speed. Suppose a CD player makes 480 revolutions per minute. So 480 revolutions for 1 minute. Now, how many degrees? So they want degrees. So right now we have revolutions, but we need to change that into degrees. And well, the point on the edge, so on the outside edge of a CD, it doesn't really matter, but this point, okay, we'll move into seconds. So now we need seconds at the end, and we need degrees. So in order to do that, we're going to make some conversions. So the first thing we want to do is that a revolution really means 480 times 360, because there's 360 degrees, and one revolution is the same thing as 360, and 1 minute is 60 seconds. So now we're in degrees and seconds. So at the top, we have 172,800 degrees, and at the bottom we have 60 seconds. So there's two ways to get the final answer. If you want to know how long it goes in 2 seconds, is if you want to make the denominator 2. So we're not doing any more conversions, but in order to make the denominator 2, you have to divide by 30 at the top and bottom. So when I do that, I get 2 seconds, and then at the top I get 5,000, or excuse me, 5760 degrees. So it'll go 5,760 degrees in 2 seconds. If you wanted to divide this, then you could also get, there's different ways of doing this. So you could divide by top and bottom by 60, and that would give you twice or half as much as that, and then you can multiply it by 2. You could, if you did 480 revolutions, well, anyway, there's different ways of doing this. I don't want to confuse you and give you a million different things to do, but there are other ways. Okay, actually, let me just do one other way so you can see. So I could have done 480 revolutions instead of a minute. We'll change that to 60 seconds. And then I could just reduce this. So that would give me 8 revolutions in 1 second, which would mean it would be 16 revolutions in 2 seconds. So then there would be 16 revolutions in 2 seconds, which would give you the same answer. So more than one way to do the same thing. Go ahead and try the last problem, and then unpause it once you're finished so you can see if you got the right answer. I'm going to do 270 revolutions in 1 minute, which equals 270 times 360 in 60 seconds. And I'm going to multiply that out, so that will give me 97,200 degrees in 60 seconds. Because they want us to figure out in 5 seconds, you can divide them by 60 and then multiply by 5. Or I'm going to divide top and bottom by 12, because I know that 60 divided by 12 is equal to 5. So if I divide the top and bottom by 12, then I will get 8,100 degrees in 5 seconds. And that's it for the first section of the year.